All right, this is grade 6, unit 2, lesson 5, and in this lesson, students are going to continue practicing and thinking about equivalent ratios. Nothing too formal, but we're starting to move towards that formal way of thinking about ratios and equivalent ratios using multiplication, and we're moving towards that in this lesson, so let's get started. All right, so we're going to begin with the classic number talk, although this one's a little bit different. We're going to be talking about dots. And I've got a card right here, a card right here, and behind that card is some dots. And the idea, parents and teachers, is we're going to reveal the dots for just a brief period of time. Students are going to kind of get a glimpse at of what the dots look like. We're going to cover it back up. And then students think about what would be an efficient way of counting all the dots in their mind, given the fact that they can't actually see it. And so you're going to give them like 3 seconds or so. So it's going to be like 1, 1,000, 2, 1,000, 3, 1,000. And then you cover it back up and you say, well, how many dots did you see? And you let the students think about it. And then you, after a little brief period of time, you're going to say, I'm going to show it to you again. 1, 1,000, 2, 1,000, 3, 1,000. Done. And then you let them talk and think about it with one another, and you share, right? And that's the idea. And then we've got another one over here. And you say, okay, but this one's going to be a little different. It's going to be half dots. 1, 1,000, 2, 1,000, 3, 1,000. Boom. And the idea is their job is to think, how would they count those number of dots now that they can't see them? And how are they going to put those half dots together? So we can reveal. And now students might be saying things like, well, I thought I saw groups of 9, but I wasn't sure how many groups there were, so I guessed, and I just did 9 times. I thought there were 7 groups, so I did 9 times 7, but of course it turns out there's only 6, and that's the point. The point is not to get the right answer. The point is to be thinking about your thinking and thinking about efficient ways of counting the dots since you didn't have enough time to actually count them one by one. Same idea with the half dots. The idea might be to say, well, I imagined that there was a grid and I thought there was like 6 across by 7. And I don't know if that's right. 1, 2, 3, 4, 5, 6. Yeah, it is 7. Okay. So 6 times 7 is 42, but they were half dots, so 42 divided by 2 gave me 21 actual dots. And that's the idea for this number talk. So here we've got this recipe for a tuna casserole. 3 cups of, you could read it yourself. Pause the video if you need to read the actual ingredients. And what we're supposed to do is we're combining the pasta and all this sort of stuff. We're going to transfer it, put the remaining cheese. So these are the instructions for how to cook this wonderful tuna casserole. I have no clue if that's legit. I'm dying to know if somebody could share in the the comment section down below if this is a legit casserole recipe. But the question is, down here, what is the ratio of ounces of soup to the cups of shredded cheese to the cups of pasta in one batch? So we've got ratio of soup to cheese to pasta. So, all right, so we've got to kind of zoom in here, and we're going to look for soup. Where's soup? I'm looking for soup. Soup there. To cheese, where's cheese? Cheese to pasta. Where is the pasta? There's the pasta. All right. So soup to cheese to pasta. So what is the ratio? So it's going to be 10 ounces to 1 cup to 3 cups. All right. So the ratio is 10 to 1 to 3. There you go. 10 to 1 to 3. But then they're asking us, so how much of each of these 3 ingredients would you need to make twice the amount, or make half the amount, or 5 times the amount, or 1/5 the amount? Great. So we're going to do that. So we know that we started off with that ratio of 10 to 1 to 3. All right, so we're going to start there, and let's get that written down right here. So we started with that ratio of 10. You know what I'm going to do? I know what I'm going to do. I'm going to erase this because it was cups. Yikes. Cups. Wait, 10 ounces. It was ounces to cups to cups. All right? And that ounces was ounces of soup. The cups, the first cups was cheese. And then the final cups was pasta. All right, so there is our little setup, right? And we started with the ratio of 10 to 1 to 3, right? 10 to 1 to 3. Now, if we want twice the amount of casserole, we just have to double all of those numbers. And so we're going to get 20 to 2 to 6. 20 to 2 to 6. Half the amount of casserole means we have to take each of these values over here, the original recipe, we have to cut them in half, right? So we're going to cut it in half, and we get 5 to a half to 1 1/2. We could have called that 3 halves, couldn't we have? Because you just take the 3 and cut it in half. So then we want 5 times the amount right down here. We want 5 times. So sure, we could do that. 5 times the amount means we're going to take each of the original values, each of the original ingredients, multiply by 5. So 10 times 5 becomes 50. 1 times 5 is 5. 3 times 5 is 15. So there is our 5 times the amount. And finally, 1/5. Okay, we don't have to freak out. We know fractions. We could divide by 5. 1/5. Easy way to do that is to divide by 5. So 10 divided by 5 is 2. And then 1 divided by 5 is 1/5. That's what we've been doing for a lot of our practices in the past few lessons, has been practicing this. And then lastly, 3 divided by 5 is 3/5. And there we go. So finally, we're kind of coming around to the end. And what is the ratio of cups of pasta to ounces of tuna in one batch? Okay, so we need to look for that. So the cups of pasta to ounces of tuna. So let's see, cups of pasta. Where's cups of pasta? Oh, there's cups of pasta. So we've got cups of pasta is 3, 2, and then the ounces of tuna. Where's ounces of tuna? There it is. So the ounces of tuna is 6. So our ratio for question number 3 is 3 to 6. There's our ratio. So then lastly, for question 4, how many batches of casserole would you make if you used the following amounts of ingredients? So if we used 9 cups of pasta and 18 ounces of tuna, how many batches is that? Well, we know that if the original was 3 to 6, and then suddenly we're jumping to 9 to 18, what did we do? It means we multiplied everything by 3. So we just made 3 batches of that casserole. And then if we had 36 ounces, oh my goodness. So if we had 36 ounces of tuna to 18 cups of pasta, what did 36 ounces of tuna? Oh, did you see how I goofed up? Over here, I goofed up because they are switching it around on us, because that 3 was originally supposed to be the pasta, and that 6 was originally the tuna, right? And so then all of a sudden they're switching it up on us, and I didn't notice. That's kind of cool. So I got to erase that, because down here it says 36 ounces of tuna and 18 cups of pasta. So the 36 needs to be over here. Ooh, that's tricky. So they got 36 and then 18. So if the original was 3 to 6, and then all of a sudden it's 18 to 36, what did we multiply by? Well, we took that 3 and we multiplied by 6 to get 18. We took the 6 and multiplied by 6 to get 36. So that means we did 6 batches of the casserole. And finally, if we have 1 cup of pasta, now they're not going to trick me on this one, 1 cup of pasta and 2 cups of tuna right here. So if that means we have 1 cup of pasta, 2 cups of tuna. So if the original is 3 to 6, how did we get down to this 1 to 2? Well, we'd had to take that 3 and we had to divide by 3 to get 1, and we had to take that 6 and we had to divide by 3 to get 1/2. So that means what kind of, how much of a batch did we do? We did 1/3, oops, right here. We did 1/3 of a batch. Ooh, that's cool. That's a really good one. All right, that's a beautiful problem. So here it says, is the ratio 5 to 12 equivalent to these two ratios, either of these two ratios? So we're going to start with that 5 to 3, 5 to 3, and then we've got the 10 to 6, all right? Good. All right, and we know that those are equivalent. How do we know that they're equivalent? Because if you take the 5 and double it, and you take the 6 and double it, take the 3 and double it, so I'm multiplying by 2 in both cases. That means those two ratios are equivalent. So if I stick 15 twelfths in there, is that an equivalent ratio? Well, we see going from 5 to 15, that's times by 3, but going from 3 to 12, ooh, that's times by 4, so that is definitely not equivalent ratios. Those are 15 twelfths is not, 15 to 12 is not an equivalent ratio. So how about 30 to 18? Right here, 30 to 18. Well, let's stick it in our list, 30 to 18. And then if we jump from 5 to 30, that's multiplying by 6. And if we go from 3 to 18, that is also multiplying by 6. So therefore, it is, yes, it is an equivalent ratio. Now, question 3 says, give 2 more examples of ratios that are equivalent to 5 to 3. So all we have to do is start with that 5 to 3, and we have to multiply it by some sort of factor. All right, so I'm going to kind of squeeze this in right here. So 5 to 3. I don't know, let's multiply by 4. So multiply by 4. And so that gives us 20 to 12. And then, I don't know, let's multiply by 9. So multiply by 9, multiply by 9. So 5 times 9 is 45. And 3 times 9 is 27. So 20 to 12 is one equivalent ratio, and 45 to 27 is another equivalent ratio. And of course, there are an infinite number of ratios that we could have created there. So the question 4, how do you know when ratios are equivalent? It's when each item in your original ratio is multiplied by the same factor. You could think of it as making batches of casserole. That's how you know if they are equivalent or not equivalent, because if they're not equivalent, if one number is being multiplied by 9 and then the other number is multiplied by something other than 9. So if these two numbers, the original elements of that ratio, are being multiplied by something different from each other, then the two ratios are not equivalent. So what's the definition of equivalent ratios? I'm going to let you kind of answer that, piecing together everything that we've talked about. So in a summary for this quick lesson here, this is beautiful. This is a really nice lesson. The idea is we know that two ratios are equivalent to each other. In this case, 9 to 6 and 18 to 12. We know that those two ratios are equivalent because both items got multiplied by the same thing, and in this case, it happens to be 2. If one number is a 2, that is being the multiplier is a 2, and the other number, that the multiplier, is something other than 2, that means those two ratios are not equivalent. All right, so it's time to do our practice. So let's take a look. Number 1, each of these is a pair of equivalent ratios for each pair. Explain why they are equivalent. So how do we know that 4/5 and 8/10 are equivalent? How do we know? Well, because each of these items are multiplied by 2 to get each of these items, so therefore it is equivalent. So how do we know that these two? Well, that's C, but we could do it. How do we know? Well, because each of the items in this ratio are multiplied by, goodness gracious, let's see, 5,000. Multiplied by 5,000, and that's how we get the new ratio. So therefore, it works. 2 times 5,000 is 10,000. 7 times 5,000 is 35,000. Similarly, you can backtrack to question B. How do we know? Now, we can either think of division or we can think of multiplication. Either way, you don't always have to go from left to right, in which case we'd be thinking about division, or we could be thinking about multiplying by a fraction. Our choice, right? Or we could start with the right and think about multiplying and going to the left. For example, 6 times 3 is 18. 1 times 3 is 3. Therefore, our two ratios are equivalent. All right, so moving to question 2, explain why 6 to 4 and 18 to 8 are not equivalent fractions. Well, we can see that 6 times 3 gives us 18, but 4 times 2 is 8, and therefore they're not equivalent ratios. Number 3, are the ratios 3 to 6 and 6 to 3 equivalent? Nope, they are absolutely not equivalent. How do we know? Well, because 6 times 2 is 6, but 6 times a half is 3. Yes. I know that we could go 3 times 2 is 6 this way, but then you would have 2 times 6 going to the right. A times by 2 going to the right, and then you'd have a times by 2 going to the left. No good. We're always, our multiplier is always going in the same direction, either multiplying both terms on the left to get the right, or multiplying both terms on the right to get to the left. So, number 4. This diagram represents 3 batches of light yellow paint. So we got a bunch of white cups, and we've got a bunch of yellow paint cups. So draw a diagram that represents one batch of the same shade of light yellow. So this represents 3 batches. So somehow we have to imagine all of this cut into 3 pieces so that we can see those 3 individual batches. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 divided by 3 means 3. 3 cups of white. And then we have to similarly count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cups of yellow. Divide by 3 gives us 5. So there, 1, 2, 3, 4, 5, there. So if we want to see what one batch would look like, that would be these 3 white and those 5 yellow. We could do these 3 white and that 5 yellow. And then lastly, we could do these 3 white and these 5 yellow. And there are our 3 individual batches. So if we wanted to draw a diagram of one batch, we would have to, for white and yellow, we would have to do 3 white cups and 5 yellow cups. All right, number 4. In the fruit bowl, there are 6 bananas, 4 apples, and 3 oranges. So for every 4 apples, there are 3 oranges. All right. The ratio of blank to blank is 6 to 3. Well, there's our 6, there's our 3. So the ratio of bananas to oranges. So I'm going to use the letter O, B and O. And the ratio of blank to blank is 4 to 6. Well, here's our 4, here's our 6. So the ratio of 4 of apples to bananas is 4 to 6. And then for every 1 orange, there are how many bananas? Well, there's 3 oranges, 6 bananas. So if you take those 3 oranges, divide by 3, you get 1 orange. So you're going to take these 6 bananas, divide by 3, you get 2 bananas. All right, moving on. This is good. This is good stuff. A little bit of review. Write fractions for the points A and B. So we need to be thinking about if this whole thing represents one whole, we can see that that whole has been cut into 1, 2, 3, 4, 5, 6 intervals. So that whole is really 6/6, which means A is 2/6, 3, 4, 5, and B is 5/6. If you really want to get picky, you can label A as 1/3 because there's a piece, there's a piece, and there's a piece of the whole was cut into 3. But it doesn't say anything about simplifying, so 2/6 is just fine. And that wraps up our practice. All right, that wraps up Grade 6, Unit 2, Lesson 5. Students continuing to practice equivalent ratios. If you have any questions, down in my description box, down there is my email address. So feel free to send me an email. Thanks.